Okay, so again, let's go ahead and take notes. We're on page 150. We're not going to talk about page 150 just yet. We're going to talk about some review, but we'll be joining page 150 soon. For now, we're in our reflective journals, titling this Chapter 2 Notes. Are you ready to go? Excellent. First and foremost, a topic that was in one of your homeworks and in the textbook pages that you worked on, but we didn't specifically cover in class, is the law of detachment. So I'm going to teach the law of detachment so that we are all on the same page. Now, when you hear the word detachment, what do you think of?
Separating.
Separation. Anything else? Apart? Great. So, detachment is the separation or the separation of a hypothesis and a conclusion. This is called a what?
If A, then B.
If A, then B is called a? Conditional statement. Yes. So here we have a conditional statement. If a hypothesis, then a what? Conclusion, yes. The law of detachment is used only to prove a conclusion. So that means, write this down, this is question 1. We'll be practicing various different questions today. You are given the conditional statement, if A, then B. It is given So the question is, if A, then B is your conditional statement, it is given that A is true. What can you conclude? So class, given that A is true, what can you conclude is also true? What would be your answer? Using the law of detachment, what would you conclude that is true? If A is true, then what is true?
B.
Yes. B is true. That is what the law of detachment looks like in practice. Again, if A is 100% true as a given, and you have a conditional statement, if A then B, the law of detachment proves that if A is true, then B is also 110% true. Now, I'm going to start by talking about the format AV, but we're actually going to talk about a real life example. So, class, can you please give me various conditional statements until I find one I can work with? So again, just raise your hand and volunteer with a conditional statement. Anything under the sun. Waiting for any conditional statements. I want to hear a couple. Christina, thanks for volunteering. Can you share any conditional statement that's on your mind?
If you're vegetarian, you don't eat meat.
Yes, great. If you are vegetarian, then you don't eat meat. So we're going to be working now on question 2. Go ahead and copy this down. If you are vegetarian, then you do not eat meat. If you are vegetarian, then you do not eat meat. This is the conditional. This is true. Who can tell me the converse? Who can tell me the converse? Jose? Yes, if you do not eat meat, then you are vegetarian. That's the converse, great work. There's also the inverse and the contrapositive. But go ahead and keep the converse in your back pocket because it's going to be relevant. Now, it is given that Steve is vegetarian. What can you conclude? This is question 2. What is the answer? Again, this is what the question would look like. I'm going to read it to you because I haven't given everything, okay? You are given the conditional statement, if you are vegetarian, then you do not eat meat. It is given that Steve is vegetarian. Using the law of detachment, what can you conclude?
He doesn't eat meat.
What was that, Ariel? What you were going to say?
I was going to say that he doesn't eat meat.
Yes. So you can conclude Steve does not eat meat. So again, let's make sure we're taking notes. This is the second question. Are we taking notes? It's going to get trickier, so please take notes. Excellent work. Thank you. So that is question 2. The answer is you can conclude Steve does not eat meat. Now, is this pretty easy?
Yeah.
Yes or no?
Yes.
Yes. So there must be something to it. There must be a trick, isn't there? You betcha. In fact, does the people who make the tests love tricks? Yes, they do. They love to play tricks. But are they going to get you? No, you're not. You're not going to get tricked because we're going to practice and prepare. So this is going to be question number 3. It's going to look very similar. I just need you to copy the red down again, okay? Only copy the red. Question 3. It is given that Steve does not eat meat. What can you conclude? It is given that Steve does not eat meat. What can you conclude? Sierra says that you can conclude Steve does not eat meat. That's one answer. Do we have any other answers? What can you conclude? So, raise your hand if you kind of thought the answer might be Steve is vegetarian. Raise your hand if you thought. Okay? Now, Jose, that was the converse, right? If you are vegetarian, then you do not eat meat as a conditional. The converse is, if you do not eat meat, then you are vegetarian. Is that statement true? No, it's false. So the point is, the law of detachment cannot prove a converse, which means the law of detachment can never prove a hypothesis. So again, only prove a conclusion, not a hypothesis. It is given that Steve does not eat meat. Does not eat meat is the what? The conclusion or the hypothesis? The conclusion. So they're giving you the conclusion. Can you use the conclusion to prove the hypothesis? No. Can you use the conclusion to make another conclusion? No. And honestly, Steve does not eat meat. Maybe he is fasting. Maybe he's vegan. There's so many possibilities. How many assumptions can we make in geometry? 0. So, you cannot conclude anything. Do we see that? Again, if you're given a hypothesis, you can conclude the conclusion using the law of detachment. But if you're given the conclusion, you cannot conclude anything. Capiche? Excellent. Let's go ahead and move on to question number 4. This realm is one of my favorites. So we're stepping into a very near and dear law of Mr. Rivera's, the law of syllogism. It's fun. the law of syllogism. So here, this is question 4. If A, then B. If B, then C. The answer will be a third conditional statement. What other conditional statement can you create using these two conditional statements? Go ahead and write that down. The law of syllogism. Does anyone have a guess? If A then B, if B then C? Renzo? Give it a shot. What do you think would be the third conditional statement?
If not A, then not B.
Okay, I like where you're thinking. A leads to B, and B leads to what?
C.
So A is leading eventually to what?
B.
C.
Yes. If A leads to B, then B leads to C. A is eventually leading to C. So the third conditional statement under the law of syllogism is if A, then C. If A, then C. Now, are you ready for Mr. Rivera's tried and true method to always getting the correct answer? Are you ready for that?
Yeah.
If you do this, I guarantee you, every time you see a law of syllogism question, if you do this, you will 110% get the right answer. Are you ready? All you have to do is look at the two conditional statements and cross off what repeats itself. Don't look at the words if or then, obviously they're going to repeat. What repeats itself? What do you see twice?
B.
B. So we cross off this B, we cross off this B, and we are left with the new conditional statement. So all you do is whatever wasn't crossed off, you don't change it, you don't switch it, you don't add anything to it, you don't take anything away from it. You keep it exactly as you see it. If A, then B. Sorry, if A, then C. So you can think of that as a process of elimination. You eliminate the duplicate. As long as you eliminate the duplicate and you don't change anything, you just push it down, you will 110% get the right answer. Capiche? Great. So let's go ahead and try a 5th question. Are we ready? It's going to get just a little bit trickier, but not that much trickier. So, underneath the law of syllogism, we have
Are those Z's?
this is question number 5. Yes, this is a Z. Create your new conditional statement using the law of syllogism, aka the process of elimination.
Ooh, don't do that. You almost got punched in the face.
Nah,
do that.
Yeah,
I
I
can
see
see
it.
it. I got it.
Can you see Mo? What do you think the answer is going to be? Who can tell me? Brian? Yes, if X then Y. So again, we're going to cross off the duplicate. What is duplicating? Z. Wait 1 second. This is my good one. That's a good one. So the Z is duplicating without making any changes. Again, no changes, nothing. We just drag and drop, okay? So we get if X, then Y. Now pay very close attention. Even though this is technically coming first or it's above, that doesn't matter. You drag and drop. If X, then Y. Capiche? Great. Does that seem pretty easy? Raise your hand if you think you got it. Raise your hand if you think you got it. Sierra, Alana, raise your hands. Nice and proud. Great, great. Donjay, do you got it?
Yeah.
TJ, do you got it? Yeah. Great. Now, Elvin, do you got it? Yep. Great. So, keep your hand in the air if you don't like algebra. Keep your hand in the air. Oh! So we all understand the geometry of the law of syllogism, but we don't like algebra. So this is pretty easy, right?
Yeah.
Are they going to try to make it tricky?
Yeah.
Yes, they are. So are you going to be taking an algebra test or a geometry test? A geometry test. So are they going to give you a geometry question or an algebra question? A geometry question. However, to the untrained eye, it's going to seem like it's an algebra question. But you're going to know better, right? They know you don't like algebra. So they know that if they throw you an algebra question, you might fumble and give up. Are you going to give up? No. So are you ready for the next question? Now, this is as complicated as it gets. This is like the final boss of the law of syllogism. Are you guys ready for your final boss? All you have to do to be successful is remember the process of elimination. Are you ready? This is what a question on the law of syllogism could look like.
Oh yeah, I'm gonna know right now.
So again, using the process of elimination, drag and drop. Is this an algebra question or a geometry question?
Okay,
Oh, I got it.
this makes sense now.
Yes, exactly. Think of it. Is this an algebra question or a geometry question?
Geometry.
Geometry. They're just trying to scare you. Don't get scared. Use the process of elimination. Do you think you got it? Get ready to tell me. Great work. Do you think you got it? Use the process of elimination. What do you see repeated? So again, it helps to write the question down. It'll make it much more clear, right, Renzo? Okay, keep working. You're doing great, Renzo. Alvin, keep working. You're not gonna get tricked by a silly question, are you? You got this, Alvin. Okay, so using the law of syllogism, what repeats itself?
3x equals 15.
So we cross off 3x equals 15, and we drag and drop. Are we changing anything?
No.
Are we solving anything? Are we using our brain cells? No. Drag and drop and move on. So that means the answer is if g of h is equal to x cubed plus 2x minus 7, then h of g is equal to 2x cubed plus 2x squared. Ding, 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 ding. You get the point and you move on. Excellent, right? Now again, to the untrained eye, would you skip that question?
Yes.
Totally. It looks like the hardest question in the world. It looks like you're gonna have to take a graphing calculator. It's gonna take 10 minutes. It looks complicated. In reality, was it very easy?
Yes.
Yes. So again, I want to empower you to succeed. We're not gonna play the fool. No, no, no. Not in geometry AI, okay? Great, 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 great. So, are we ready for the last stretch? Great. Do you guys feel confident about this now?
Yeah.
Yeah.
Great. No matter how scary, it's really the law of syllogism. Every time you see a law of syllogism question, I want you to smile because it should be easy, okay? Now we're officially on page 150. So if you look at page 150, you should see key ideas. That key ideas is power-packed with 9 different properties. Again, the key idea on page 150 has 9 different properties. I'm going to break them down. Go ahead and look for a fresh place in your notes. If you have only a little bit of room, I would go ahead and go to a brand new page because this is big. This is huge, okay? So again, the bigger the better, okay? Make this really big in your notes. We're going to discuss properties, some new properties. They're kind of like laws, but we call them properties, and we use them as justifications. Yesterday we talked about the addition property of equality, remember? And the subtraction property of equality, the division property of equality, the multiplication property of equality, the distributive property. Remember that? Yes or no?
Yes.
Yes, great. Now we're going to learn about some more. First and foremost, let's talk about the reflective property. The reflexive, sorry. So here we have reflexive. Reflexive sounds a lot like what word?
Reflect.
Reflect. And what reflects?
Mirrors.
Mirrors. Excellent. Excellent. Mirrors do reflect. That is huge.
Oh, this is actually better?
Yes. Put your name on it. So when you think of the reflexive property, think of a mirror. If you walk up to a mirror wearing a red shirt, are you going to see your reflection with the blue shirt?
No.
No, you're going to see your reflection with the what shirt?
Red.
The red, that is correct. So, using real numbers, the reflexive property is a 1-to-1 relationship. Or you can think of it as just 1. So that means that 7 is equal to what?
7.
Yes. 7 walks up to the mirror and sees a 7. X walks up to the mirror. What is X going to see?
X.
X. Excellent. We can also use the reflexive property. So this is the reflexive property of real numbers. We can also have a reflexive property of segment lengths. This is your second one. The reflexive property of segment lengths. You can have something like line segment AB is equal to what?
AB.
Yes, line segment AB. And we can even do it for angle measures. Angle measures. The measure of angle A is equal to what?
Angle A.
The measure of angle A. Yes, that is correct. There you see 3 different properties. The key word here is the word reflect. Think of a mirror. You make no change. You do absolutely nothing but reflect and copy what you see on one side of the equal sign to the other. So under the reflexive property, 7 equals 7. Measure of angle A equals the measure of angle A. Now remember class, we're teaching an alien to brush teeth. Is this obvious? Very obvious. But we have to put a name to it. We have to teach that alien. So this is the reflexive property of real numbers, the reflexive property of segment lengths, and the reflexive property of angle measures. Are we ready for the next one?
Yeah.
Yes. So the reflexive is a 1. The symmetric is a what? Yes, symmetric. Can somebody please use symmetric in a sentence? Who can use symmetrical in a sentence? Imagine you're sitting at lunch, you're talking with friends. Why would the word symmetrical come up?
The way you're sitting.
Your makeup looks symmetrical. What else?
Your face.
Your face. When you're talking about a symmetrical face, what exactly are you comparing?
Symmetry.
Both sides.
Both sides. What are the sides?
Equal.
Left to right.
left and right. Again, the left and right. Now, do you see how left and right there are two different things? So think of the symmetric as twins, but not identical. They're fraternal. Twins or one pair. So the reflexive is literally it in itself. The symmetric is a left and a right, a 1 and a 2. So metric would be if x equals 4, then 4 equals x. Okay? Is that pretty obvious?
Yes.
You can also think of it of if A equals B, then B equals A. If Z equals 10, then 10 equals Z. We can also have symmetric property of segment lengths. If x equals, if line segment XY equals line segment AB, then what?
AB equals XY.
Yes, AB equals XY. And we can do it for angle measures. So if the measure of angle A is equal to the measure of angle B, then what? Right? The reflexive is two things just reflected. Sorry, symmetric. Are we ready for the last one? The last one is the transitive. Transitive. So the reflexive was 1, the symmetric was 2. How many do you think the transitive is?
3.
3. And when we think of the transitive, we can think of the law of syllogism. So write this down. Class, on Friday, it's looking really good. Let's go ahead and finish. I know the bell's about to ring, but finish these notes and I will stay true to my promise. So, if x equals 4, sorry, it's better to do it like this. So, if A equals B and B equals C, then A equals C. That's the transitive property of real numbers. The transitive property of segment lengths is if XY equals AB and AB equals CD, then what, class?
XY equals CD.
Thank you. Excellent. And last but not least, the transitive property of angle measures. If the measure of angle A equals the measure of angle D, and the measure of angle D equals the measure of angle J, then what?
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 Excellent.
Congratulations.
So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different properties. If you do your alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T. 1, 2, 3, R, S, T. That should help. Pretty cute, huh? Yes. That concludes. Your homework tonight is on what, class? Big ideas. Yes, thank you.